Dear students, welcome back to a new mathematics session. In today's session, we shall discuss a new concept from the chapter Matrices, that is transpose of a matrix. Let's move on to the topic. Let's discuss transpose of a matrix. If A is equal to matrix Aij be an m by n matrix, then the matrix obtained by interchanging the rows and columns of A is called the transpose of A. It's a quite simple definition and easy concept as well. Suppose there is a matrix A is equal to the general form, that is matrix Aij, and its order is m by n. Then if we change the rows and columns, means if we interchange the rows and columns of this matrix A, then we will get the transpose of A. To get the transpose of a given matrix means what we supposed to do is just interchange the rows and columns. Interchanging means rows becomes columns and columns becomes rows. That's all. Then we will get the transpose of the given matrix A. And it is usually denoted by the symbol A dash or A power T. Matrix A, transpose of the matrix A is denoted by A dash or A power T. Let's take an example. A is equal to matrix 1, 2, 3. As the matrix shows, it is having only one row and there are 3 columns, and it is called a row matrix. It is having only one row. So to get the transpose of this matrix, what we supposed to do is this row you have to write as column. We have only one row, then this row will come as column. That is A transpose is equal to this 1, 2, 3 will be coming as column here. 1, 2, 3. So here it was in row, but here it is there in column. So A is matrix 1, 2, 3. Then A transpose is also matrix 1, 2, 3. But this 1, 2, 3 we are writing in column wise. One more example. A is equal to matrix ABC, DEF, GHI. It is a 3 by 3 matrix. 3 rows and 3 columns. To get the transpose of this matrix, change the rows. Interchange the rows and columns. Means here first row is ABC. But when you write the transpose, first column will be ABC, and the second row is here DEF, and when you write the transpose, your second column will be DEF, and here GHI is the third row. Here when you write the transpose, it comes as third column. So A transpose is equal to, as we have discussed before, ABC first row, but here comes as the first column. DEF second row, here comes as second column, and GHI here comes as third column. So here interchanging the rows and columns. Here rows becomes, when you write the transpose, it becomes columns. Hope it is clear. Next we shall discuss properties of transpose of matrices. Here there are some properties are there for transpose of matrices. You must clearly understand that one, then only you will be able to solve the questions which is mentioned in the exercise. For any matrices A and B of suitable orders, first property is A transpose the whole transpose is equal to A. So if you are taking the transpose, one matrix transpose is there, and if you take again that transpose, you will get as A. Means A transpose the whole transpose is equal to A. The second property is K A the whole transpose is equal to K into A transpose. Here K is a scalar quantity. K A the whole transpose means just simply take out K and keep it outside, and then you can take A transpose alone, where K is any constant. Next property, A plus B the whole transpose is equal to A transpose plus B transpose. If you take the sum of two matrices and taking that sum's transpose will be equal to individual transposes you can take and you can add. A plus B the whole transpose is equal to A transpose plus B transpose. And the fourth one, AB the whole transpose is equal to B transpose A transpose. Here when you are multiplying two matrices AB, first matrix is A and second matrix is B, then if you take the transpose, that will be equal to second matrix transpose into first matrix transpose. AB the whole transpose is equal to B transpose A transpose. Move on to the exercise questions. Exercise 3.1. First question, find the transpose of each of the following matrices. Transpose, it is quite clear for us. You have to interchange the rows and columns. First one, it is a column matrix 5, 1 by 2 minus 1. Let's take this matrix as A. because when we name a matrix it will be easy to write the transpose. So A is equal to matrix 5 1 by 2 minus 1. We are asked to calculate A transpose A dash. We have to write A transpose is equal to, this is a column matrix, this column will come as the row here. So 5 1 by 2 minus 1, just interchange the rows and columns. Then the second question, matrix 1 minus 1 2 3 is order of 2 by 2. So just take this one as B. Let B is equal to matrix 1 minus 1 2 3, and here this is first row and this is second row. And when you write the B transpose, the row and columns will be interchanged. So here first row is 1 minus 1 and it comes as, first row is 1 minus 1, it comes as first column, that is 1 minus 1 here. And the second row is 2 3, here comes as the second column. So B transpose is equal to, about this step, if it is necessary only you write, it's not, if you feel that it can be avoided then just simply avoid it, because this is just a transpose of this particular matrix. Directly we can write like here, just to interchange the row and columns. So 1 minus 1 here first row, here comes as first column, 2 3 second row, here comes as second column. Then question number 3, there is a 3 by 3 matrix is given to us. We are asked to write its transpose. Let's take this as C. Let C is equal to matrix minus 1 5 6 root 3 5 6 2 3 minus 1. Here this is first row, second row, third row. So we have to interchange the rows and columns for getting the transpose. C transpose is equal to, first row will be coming as first column, minus 1 5 6 will be coming as here first column, root 3 5 6 second row, here it comes as second column, here 2 3 minus 1 third row, it comes as third column. So this is the C transpose. Move on to the second question. If A is equal to matrix minus 1 2 3 5 7 9 minus 2 1 1, and B is equal to matrix minus 4 1 minus 5 1 2 0 and 1 3 1, then verify that A plus B the whole transpose is equal to A transpose plus B transpose. This is one of the properties of transpose of matrices. So it's quite simple questions. First of all, what we have to do is we have to add A and B, then sum, you will get a single matrix. That matrix transpose you have to take. That will be your left hand side. And the right hand side, first A transpose you have to take, then second B transpose you have to take, then you have to add that two transposes. Then you have to prove that left hand side and right hand side will be getting the same matrices. Let's start solving A plus B. First of all, A plus B we need here. Just add two matrices. As we know, addition of matrices means just simply add the corresponding elements. So minus 1 plus minus 4, that will be first term, and the next is 2 plus 1, that is returned. Then 3 plus minus 5, it's here. 5 plus 1, it's returned. Then 7 plus 2, it's here. Then 9 plus 0, it's this one. Minus 2 plus 1, that is the first element in third row. 1 plus 3, second element. 1 plus 1, that is the third element. So this step is not compulsory. If you wish to write, or else directly we can write the added elements. So minus 1 minus 4, that is minus 5. 2 plus 1, that is equal to 3. 3 minus 5, that is minus 2. 5 plus 1, that is 6. 7 plus 2, that is 9. 9 plus 0, that is 9. Minus 2 plus 1, that is minus 1. 1 plus 3 is 4. 1 plus 1 is 2. So this is our A plus B. What we required is A plus B the whole transpose. So let's calculate A plus B the transpose. This is A plus B. Just interchange the rows and columns. Means first row comes as first column and so on. So here 5 3 minus 2, that is the first row. It comes as first column. 5 minus 3 minus 2. 6 9 9, that is the second row. That comes as second column here. Minus 1 4 2, third row, that comes as third column here. So this is our left hand side, A plus B the whole transpose. Let it be here. Then we have to move to the right hand side, that is A transpose we need to calculate. For that, A we have written, that is minus 1 2 3 5 7 9 minus 2 1 1. Then when we write the transpose, it comes as first row first column will be changing. That is minus 1 2 3 here comes as first row. This is first column. 5 7 9 second row. Here is second column. Minus 2 1 1 third row, that comes as third column here. Then we need next again B transpose. For that, B we have to write from the given matrix. Minus 4 1 minus 5 1 2 0 1 3 1. This is B. We need B transpose change. first row minus 4 1 minus 5 comes as first column. 1 2 0 second row comes as second column. 1 3 1 third row comes as third column. Then we need A transpose plus B transpose, means we need to add these two. Just add it. As we know that addition means adding individual elements. Minus 4 plus minus 1, it's written. 5 plus 1, that is here. Minus 2 plus 1, that is written. 2 plus 1, that is written. 7 plus 2, that is here. 1 plus 3, that is here. 3 plus minus 5, it's mentioned. 9 plus 0, it's mentioned. 1 plus 1 is here. Then just write down the answers. Minus 1 minus 4, that is minus 5. 5 plus 1, that is 6. Minus 2 plus 1, that is minus 1. 2 plus 1, that is 3. 7 plus 2, that is 9. 1 plus 3 is 4. 3 minus 5 is minus 2. 9 plus 0 is 9. 1 plus 1 is 2. Now this is our right hand side. Let's check. Left hand side is minus 5, 6, minus 1. Here also first row same. 3, 9, 4 means second row also same. Minus 2, 9, 2. Third row also same. Means A plus B the whole transpose is equal to A transpose plus B transpose. Hence the proof. Next we shall discuss the second question. A minus B the whole transpose is equal to A transpose minus B transpose. This question you will do it as homework. Then third question. If A transpose is equal to matrix 3 4 minus 1 2 0 1 and B is equal to matrix minus 1 2 1 1 2 3, then verify that A plus B the whole transpose is equal to A transpose plus B transpose. So here when you check, A transpose is there but A is not there. Here B is there. So from A transpose, how do we calculate A? By using its property. A transpose the whole transpose is equal to A. Means if you take the transpose of this matrix, we will get A. That is the way we are going to do. So given A transpose is equal to matrix 3 4 minus 1 2 0 1, then by using the property A is equal to A transpose the whole transpose. Means A transpose is this one, we have to take the transpose of this matrix. 3 4 minus 1 2 0 1 the whole transpose. Means just interchange the rows and columns. Here first row will be coming as first column, second row will be coming here as second column, third row will be coming as third column. It's written. Next is A plus B. So that is what the left hand side portion. A plus B we want to calculate. Just add the two matrices A and B. For adding the matrices we need to add the corresponding elements. 3 plus minus 1 it's written. Minus 1 plus 2 it's written. 0 plus 1 it's mentioned here. 4 plus 1 it's written. 2 plus 2 that is here. 1 plus 3 that is also mentioned. Do the calculation. 3 minus 1 is 2. Minus 1 plus 2 is 1. 0 plus 1 is 1. 4 plus 1 is 5. 2 plus 2 is 4. 1 plus 3 is 4. So this is A plus B. What we need is A plus B the whole transpose. So A plus B the whole transpose is equal to, interchange the rows and columns. First row is 2 1 1 for A plus B. For A plus B the whole transpose, that comes as first column 2 1 1. Then second row 5 4 4 will come as second column here. That is A plus B the whole transpose. Then when we move on to the right hand side, there A transpose and B transpose we need to add. So B is there. A transpose already we have given to us. We have with us this A transpose. So we need only B transpose. For that B we have written. B transpose means row will come as column. Second row here, second column as in B transpose. So just add A transpose plus B transpose. A transpose is given to us 3 4 minus 1 2 0 1, that is here. B transpose we have calculated. For sum, just add the individual corresponding elements. 3 plus minus 1 it's mentioned here. 4 plus 1 it's here. Minus 1 plus 2 it is here. 2 plus 2 that is second element in second row. 0 plus 1 first element in third row. 1 plus 3 that is second element in the third row. Then when we do the calculation, 3 minus 1 is 2. 4 plus 1 is 5. Minus 1 plus 2 is 1. 2 plus 2 is 4. 0 plus 1 is 1. 1 plus 3 is 4. Let's check the right hand side and the left hand side. Here also 2 5 1 4 1 4. Here also 2 5 1 4 1 4. Means A plus B the whole transpose and A transpose B plus B transpose both are same matrices. Hence the proof. Exercise 3.3, second question. That is, if A transpose is equal to matrix 3 4 minus 1 2 0 1 and B is equal to matrix minus 1 2 1 1 2 3, verify that A minus B the whole transpose is equal to A transpose B transpose. So this question you will try it as homework. Move on to the fourth question. The question is, if A transpose is equal to minus 2 3 1 2 and B is equal to matrix minus 1 0 1 2, then find A plus 2B the whole transpose. Here we are asked to find out A plus 2B first, then we have to take the transpose of that particular matrix. So here A transpose is given, but we need A. It is quite familiar for us. How do we calculate from A transpose to A? That is, take the transpose of A transpose. So A transpose is matrix minus 2 3 1 2. That means A is equal to A transpose the whole transpose. This is a property we apply. Here A is equal to A transpose the whole transpose. So A transpose is this one. That is, when you take the transpose of this matrix, first row is minus 2 3, that comes as first column. 1 2 is the second row here, that comes as the second column. That is A now, because that is A transpose the whole transpose. That is our A. Now we need 2B. For that B we have to write first. B is given to us minus 1 0 1 2, that is written. Then 2B, scalar multiplication, just to multiply 2 outside. 2 into matrix minus 1 0 1 2. Then just to multiply inside these 2. 2 into minus 1 is minus 2. 2 into 0 is 0. 2 into 1 is 2. 2 into 2 is 4. Is mentioned. Then we need A plus 2B, that is what the left hand side, A plus 2B. So A matrix we have got here, that is minus 2 1 3 2, that we have written, plus 2B also we have calculated a single matrix here, minus 2 0 2 4. Then just add these two, that is minus 2 plus minus 2, that is minus 4, 1 plus 0, that is 1, 3 plus 2, that is 5, 2 plus 4, that is 6, that is A plus 2B. But what we need is A plus 2B the whole transpose. Means we need to take the transpose of this matrix. That is A plus 2B the whole transpose is equal to first row minus 4 1 will come as first column, interchanging the rows and columns. 5 6 second row here, that comes as the second column here. So this is the answer of A plus 2B the whole transpose. Move on to the fifth question. For the matrices A and B, verify that AB the whole transpose is equal to B transpose A transpose, where A is a column matrix 1 minus 4 3, B is a row matrix, that is minus 1 2 1. So first of all we need to find out AB the whole transpose. For that we need first AB calculation. So let's calculate AB. So here you can check the order if you want. That is, this matrix is having an A matrix is having an order of 3 rows and 1 column, that is 3 by 1. And the second matrix is having an order of 1 row and 3 columns. And you can check here, this column and these rows are equal. So the resultant matrix is having an order of 3 by 3. So these are the prerequisites. We have to just check and keep ready. So we have an resultant matrix of order 3 by 3. First row, first column, only single elements. So it is quite simple for us to multiply. So A we have written into B. Then just go for multiplication. First row with the first column. Here is only single elements. Just multiply it 1 into minus 1. It's written. First row with the second column 1 into 2. Then first row with the third column 1 into 1. Next is second row with the first column minus 4 into minus 1, it's written. Second row with the second column minus 4 into 2, it's written. Second row with the third column minus 4 into 1, it's written. Next is third row with the first column 3 into minus 1. Third row with the second column, that is 3 into 2. Third row with the third column, that is the last element, 3 into 1. Then just write the answer. 1 into minus 1 is minus 1. 1 into 2 is 2. 1 into 1 is 1. Minus into minus plus 4. Minus 4 into 8 is minus 8. Minus 4 into 2 is minus 8. Minus 4 into 1 is minus 4. 3 into minus 1 is minus 3. 3 into 2 is 6. 3 into 1 is 3. So this is our AB. We need AB the whole transpose. So take the transpose of AB. First row will come as first column. Minus 1 2 1 comes as first column here. Second row is 4 minus 8 minus 4. Just interchange it. That comes as column here. 4 minus 8 minus 4. Third row minus 363 is coming here as third column minus 363. So this is our left hand side AB the whole transpose. Then B transpose A transpose. So we have to go for first B. B is minus 1 2 1. Row matrix we have written. When we write the transpose, it comes as column matrix. First row only there, so that comes as column. Next is we have A, that is a column matrix 1 minus 4 3. Only one column is there. That here when you write A transpose, it comes as row 1 minus 1 minus 4 1. Then we have to go for B transpose A transpose. B transpose A transpose is equal to, let's write the matrices. One matrix we have written, another matrix also we have written. Here also, as before, we have to check. This is first matrix of order 3 by 1. Here is 1 by 3. Your resultant matrix will be coming 3 by 3. We have discussed before the same pattern. So just multiply it. First row with the first column. Minus 1 into 1 is mentioned. First row with the second column. So each row and each column is having only single elements, so that it is easy for us to multiply. Minus 1 into minus 4 it's written. First row with the third column, minus 1 into 3, it's mentioned here. Second row with the first column, 2 into 1, that is 2. Second row with the second column, that is 2 into minus 4. Second row with the third column, that is 2 into 3, it's written. Third row with the first column, 1 into 1. Third row with the second column, that is 1 into minus 4. Third row with the third column, that is 1 into 3. We'll do the calculation. Minus 1 into 1 is minus 1. Minus into minus plus 1 into 4 is 4. Minus 1 into 3 is minus 3, 2 into 1 is 2, 2 into minus 4 is minus 8, 2 into 3 is 6, 1 into 1 is 1, 1 into minus 4 is minus 4, 1 into 3 is 3. So now let's check the left hand side and right hand side. AB the whole transpose is minus 1 4 minus 3, same row. 2 minus 8 6, again same row. 1 minus 4 3, here also same. That means AB the whole transpose is equal to B transpose A transpose. Hence the proof. Next we shall discuss the second part. A is equal to matrix 0 1 2, B is equal to matrix 1 5 7. So here this question you will do it as homework. Then the sixth question, if A is equal to matrix cos alpha sin alpha minus sin alpha cos alpha, then verify that A transpose it into A is equal to I. A transpose into A is equal to I. I is an identity matrix of order 2 by 2, because the given matrix is of order 2 by 2, that's why. Let's write A matrix cos alpha sin alpha minus sin alpha cos alpha. Then A transpose, because we need A transpose here, row becomes column cos alpha sin alpha. Then here second row is minus sin alpha cos alpha, that comes here second column. Then A transpose into A. A transpose into A means just second matrix, that is cos alpha minus sin alpha cos alpha, that is our A transpose. Then with A you have to multiply. A is cos alpha sin alpha minus sin alpha cos alpha. Then just first row with the first column, that is cos alpha into cos alpha minus sin alpha into minus sin alpha, that is mentioned here. Then first row with the second column, that is cos alpha into sin alpha, that is written, minus sin alpha into cos alpha, that is written. Then second row with the first column, sin alpha into cos alpha, it's written, minus cos alpha into sin alpha, or plus cos alpha into minus sin alpha. Anyway you can write, it's not a problem. Then second row with the second column, that is sin alpha into sin alpha, it's written, plus cos alpha into cos alpha, it's mentioned. Matrix multiplication you must be familiar. Then that is equal to cos alpha into cos alpha, that is cos square alpha, minus into minus plus sin alpha into sin alpha is sin square alpha. Then here cos alpha into cos alpha as it is coming, then plus into minus minus sin alpha cos alpha. Then here sin alpha cos alpha as it is, then plus into minus, that is minus sin alpha cos alpha, just to change the order. Then sin alpha into sin alpha, that is sin square alpha, cos alpha into cos alpha is cos square alpha. Then as we know that sin square alpha plus cos square alpha, that is equal to 1. We know the identity. Then plus sin alpha cos alpha minus sin alpha cos alpha cancelled. Here also plus minus cancelled. And this will be equal to 1. We know that by using identity. This also will be equal to 1. So when we write it, the final answer, it comes as 1 0. This is 1. This is 0. and this is also 0, this is 1. So 1 0 0 1. This is an identity matrix of order 2, that is equal to I. So we have proved as A transpose into A is equal to I, hence the proof. Next, the second part, if A is equal to matrix sin alpha cos alpha minus cos alpha sin alpha, then verify that A transpose into A is equal to I. This question you will try it as homework. Dear students, today we have discussed the concept of transpose of a matrix, and we have solved first 6 questions from exercise 3.3. I request all the students to go through these questions and practice it. While practicing, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.